Hi, I'm Moncada with my partner, Ortilla, to discuss about Boyle's Law and Jar's Law. Hello guys, so let's start with the Boyle's Law. Boyle's Law states the relation between pressure and volume, which are inversely related to each other. With a constant temperature, when the pressure increases, the volume decreases, and when the volume increases, the pressure decreases. Boyle's law was made by Robert Boyle. Robert Boyle was the father of modern chemistry. He was a chemist and natural philosopher. He was born on January 25, 1627, and died on December 30, 1690. So, let's start to solve some problems.
Boyle's law has a formula of P1 times B1 is equals to P2 times B2, wherein P1 is the initial pressure, V1 is the initial volume, P2 is the final pressure, and V2 is the final volume. To compress nitrogen at 1 atm from 750 ml to 500 ml, what must the new pressure be if the temperature is kept constant? So, we have R given. The initial pressure, or the P1, is equals to 1 atm. The initial volume, or V1, is equals to 750 ml. The final volume, or the V2, is equals to 500 ml. And the final pressure is missing, or the P2. So, the required is the final pressure, or the P2. Okay, let's start to solve some problem. We have a formula of P1 times V1 is equals to P2 times V2. The final pressure is missing, or the P2. We need to derive the formula of this. P1 times V1 is equals to P2 times V2. Divide it both sides by V2 in order to cancel the V2. P2 is equals to P1 V1 over V2. And that is the formula for getting the final pressure, or the P2. Let's start with our solution. We have the formula of P2 is equals to P1 times V1 over V2. P2 is equals to, substitute the given value, 1 atm times 750 ml over 500 ml. Cancel the unit of volume. P2 is equals to, let's solve it with calculator. 750 divided by 500 is equals to, the answer is 1.5 atm. And that is the final pressure, or the P2. What would be the new volume if the pressure on 600 ml is increased from 90 kPa to 150 kPa? So, we have our given. The initial pressure, or P1, is equals to 90 kPa. The initial volume, or V1, is equals to 600 ml. The final pressure is equals to 150 kPa. And the final volume, or V2, is missing. So, the required is the final volume, or the V2. Let's start with our solution. We have the formula of V2 is equals to P1 times V1 over P2. V2 is equals to substitute the given value 90 kPa times 600 ml over 150 kPa. Cancel the unit of pressure, and then V2 is equals to, we need to solve it by calculator. 90 times 600 over 150. The answer is 360 ml. And that is the final volume, or the V2.
Hi guys, I'm here to discuss about Charles law. Charles law states that the volume of a gas is directly proportional to the temperature without absolute pressure. It was proposed by Johannes Alexander Charles, a mathematician, physicist, inventor. He was born on November 12, 1746 and died on April 7, 1823.
The formula for Charles' law is V1 over T1 equals V2 over T2, wherein V1 is the initial volume, T1 is the initial temperature, V2 is the final volume, and T2 is the final temperature.
A gas occupies 900 ml at a temperature of 27 degrees Celsius. What is the volume at 132 degrees Celsius?
To solve for the problem, we need first to find the given and list down the given. V1 equals 900 milliliters or 900 ml. T1 equals 27 degrees Celsius plus 273 to convert it to Kelvin is equals to 300 Kelvin. T2 equals 132 degrees Celsius plus 273 to convert it to Kelvin is equals to 405 Kelvin. V2 is the missing one. Now, we are required to find V2 or the final volume. Then, we are going to derive from the equation V1 over T1 equals V2 over T2. When V2 is the missing one and we need to find an equation for that. V1 over T1 equals V2 over T2. Then cross multiplication is equals to V1 times T2 equals V2 times T1. Divide both sides by T1 to cancel T1. V2 equals V1 multiplied by T2 divided by T1. For the solution, we have to substitute the given values from the derived formula. V2 equals V1 times T2 divided by T1. Substitution. V2 equals 900 ml times 405 Kelvin divided by 300 Kelvin. Cancel the unit Kelvin, then V2 equals, let's solve it from the calculator. 900 ml times 405 Kelvin divided by 300 Kelvin is equals to 1215 ml. And that's our final answer.
A gas occupies 1 liter at a standard temperature. What is the temperature in 2.22 liters?
First, we need to list down the given values. V1 equals 1 liter. T1 equals 273 Kelvin or the constant temperature. V2 equals 2.22 liters. T2 equals the missing one. So, we are required to find T2 or the final temperature. Then we are going to derive from the formula V1 over T1 equals V2 over T2, where T2 is the missing one. So V1 over T1 equals V2 over T2, cross multiplication, V1 multiplied by T2 equals V2 multiplied by T1. Divide both sides by V1, cancel V1 from the other side, meaning T2 equals V2 times T1 over V1. And that's our derived formula for the problem. For the solution, substitute the given values to the derived formula. T2 equals V2 times T1 over V1. So, substitution, T2 equals 2.22 liters times 273 Kelvin divided by 1 liter. Cancel the liter unit. So, T2 equals multiplication 2.22 multiplied by 273 over 1 equals 600.06 Kelvin. That's our final answer.
I hope
You understand
about Boyle's law.
and Charles' law.
Thank you.